In 2011, the launch of Siri was a milestone that positioned Apple years ahead of the rest of the smartphone industry. It was the first time a major manufacturer put a conversational assistant directly into the hands of millions. But Siri was built on a rigid, command-based architecture. As the years passed, it struggled to evolve, often misunderstanding basic requests or failing to follow the thread of a simple conversation. While Apple's assistant remained static, the industry shifted. The arrival of cloud-based large language models changed what users expected, moving the goalposts from simple voice commands to complex natural reasoning. The threat became clear with the rise of OpenAI. Their conversational AI could brainstorm, draft emails, and retain context, making Siri look obsolete. As rival tech giants rapidly deployed their own advanced generative models, a narrative began to form. Apple had missed the transition to modern AI. This stagnation created a problem for the company's core product. To stay relevant in an AI-driven market, Apple would have to reinvent its assistant or risk losing its dominance. At WWDC 2026, Apple addressed their late arrival by framing the delay as a strategy to build AI around their existing commitments to privacy and local processing. This took the form of Apple Intelligence, an isolated, on-device system. Unlike models that rely on broad internet scraping, this AI is grounded in the user's personal context. This new approach introduced a redesigned Siri interface. It has moved beyond a simple voice prompt to become an omnipresent application capable of taking both text and voice inputs across the entire operating system. Siri now searches across local emails, notes, and messages to answer highly specific questions, like retrieving a dinner reservation buried in an old message thread. By shifting the foundation from global web knowledge to local personal data, Apple has attempted to transform Siri from a search tool into a functional digital assistant. One of the primary mechanical updates is on-screen awareness. The AI can now interpret the content currently displayed on the device in real time. This allows the system to automate tasks that previously required manual effort. For instance, it can recognize an address in an email and immediately offer to open it in Maps without the user needing to copy or paste anything. These nodes represent Mail, Phone, and Calendar, illustrating cross-app intelligence, the ability to coordinate data. When needed, the system extracts a data point from its source, like a flight code in Mail, and injects it into another live application during a call. Users can initiate these cross-app actions using natural language prompts, simplifying tasks that once required navigating multiple menus. These mechanics are designed to dissolve the boundaries between standalone apps, moving the primary user interaction from individual icons to the operating system itself. Processing these AI tasks locally requires a level of computational power that older iPhones cannot provide. For the most demanding requests, Apple uses private cloud compute. This uses Apple Silicon servers to handle the processing without storing the user's data or making it accessible to the company. The catch is that accessing this network requires specific hardware. The system is restricted to devices equipped with the A18 Pro, A19, or M series chips. This baseline excludes millions of older iPhones from the update, making a hardware upgrade a requirement for those who want to use the new AI features. This hardware strategy is consistent across the entire product line, from MacBooks to the Apple Vision Pro, positioning these AI capabilities as a standard for their premium devices. Apple Intelligence is an architectural shift that turns privacy into a feature dependent on specific hardware. By setting these requirements, the company has established a new baseline for its ecosystem, where software capabilities are tethered to the power of recent silicon.